linked. 112, path sum. Given a binary tree and a sum, determine if a tree has a root to leaf path such that adding up all the values along the path equals the given sum. A leaf is a node with no children. Given a below tree and sum, and you turn 2 returns true. Okay. I think this is straightforward-ish. So yeah, let's just kind of do before. So, I mean, it is supposed to be easy. So yeah, force, and then just return as path sum. Oops. I guess it's self dot. It's still recursively, right? Because that's the cool thing to do. Maybe sum minus. Do they have negative numbers? I guess technically it could go either way. And actually, I think this is. I mean, I could do it this way, but I think the edge cases will have to be slightly different. Yeah. Turn true. And then what's the other edge case I was thinking of? Yeah, okay. I mean, this is technically okay. Your astute viewers will know that I'm doing the same thing twice, but the or should early terminate, so maybe that should be okay. That's kind of run it real quick. Yeah, are there more examples? I guess not. So let's let's test the empty example, which I'd like to do. A leaf is a node. Oh, actually, I misread this. So, so I think this would have been wrong because it's root to leaf, not just any subset. So we have to check. But that's not a hard thing. We just have to check that here. We just have to move this. Oops. And this is what you want to here. And then that should be it. Let's test another case then. Let's just say, let's actually use the example, but with a different sum. Let's say we want to look for 5, which is the root. If we terminate early, this will give me a false. And if this terminates late, then it should be a true. So we'll see which one we get. Yes, certainly reminds to us. I mean, usually I type these pretty quickly, so that's why I'll go over it afterwards for sure. Well, I knew that was. I meant to test that case, but that's just a silly edge case. Okay, fine. How do I want to handle this case in a good way? So I think the thing I just wanted to do was just keep everything in one function, but that's not necessary, by the way. It's just that it's literally just a cool thing to do. But I guess I can really handle this case without a helper. At least I don't think I don't think I have one anyway. Okay, I mean, yeah, okay. You could do something like this, right? Something like that, but then you have to do like. What a silly thing that I'm doing for an edge case. I thought that. Doesn't this? Am I doing this wrong? Or maybe I'm thinking of Python 2 syntax. Considered dangerous. Am I doing? No. True, the force if not. So if this is force, why is that visited not defined? Huh? Okay, let's just remove that because that's not important. But oh, I'm just being silly. That should be a string, obviously. So I would clarify that on a contest or something like that, I would definitely do this in two functions. I just want it to be cool, like we want the cool kits. All right, let's see if I get another silly mistake. Oh, I don't know what that tree looks like. Okay, maybe I should step back a second. Maybe I underestimated how silly I am. But I thought I tested for that case. Was it's already none. Oh, because it goes to the right path. Okay, fine. Let's just rewrite this. I try to be too cute and try to get everything in one function, but probably didn't need to do that. So let's refresh this real quick. Okay, so let's check if root is none, then return false. And then now, if let's see, if this is a leaf, that means if this is none and root dot right is none, we check the sum. If sum is 0, 0, I guess we just return sum is 0, 0. But first, we would do what we call it, root dot value. Otherwise, then we check the left and the right. Okay. I guess I'm still doing the same thing-ish. But maybe this is cleaner. Let's learn from our mistakes by copying this case. Oh, I guess I already did. Okay, so at least I'm getting progressively better. Is this thing the current one all problems? This just looks like a bug. Okay, cool. Yeah, so just general silliness aside, me watching that one. To be honest, so definitely take your time, especially if you're in an interview. I think, to be honest, if I was doing this in a contest form, I might have still watched this and got some of these edge cases as well. Because what I did was I checked whether one of his child is none, one of his child is none, versus both his children should be none. So I definitely watched that one because I don't know. And this is why you warm up, right? Because you want the silly tree things. Oh, thanks for the final, Bruno Kakuzuri. Definitely a fan of that game on an N64. But yeah, so this is a quote unquote easy problem, and it is easy. It's just that I'm silly. A lot of upvotes on this problem. Yeah, it's a tree problem. So I definitely recommend, for an interview, I would definitely study these kind of problems and get practice. Interviewers love these kind of problems for interviews, so I definitely, I don't think I have that much space for opinion, just because your interviewers love these problems. So yeah, it's just about what it is, and it's all about recursion. And yeah, tree structures have very easy-ish to understand recursion. Not easy to understand, maybe that's not the right way. Just like easy to illustrate type of recursion. So yeah, definitely all about that. Can I explain like your 5 on this one? Yeah. So basically, the idea is that yeah, recursion is the big idea, which is why this is a popular interview question. And the idea is that okay, you start with looking at the top node where the sum is 22. So then you just look, okay, is this a leaf? No. So then let's go down to one of the leaves or one of the children, which is not necessarily a leaf, and then see if you could get to 22 here. Well, Are you still looking for 22? The answer is no, right? Because you already have 5 on the top, so it's going to be 5 less. So then now it's 17. So let's go to this node and be like, okay, from this node, is there a root to leave with the sum of 17? And then so forth. And then you kind of keep on going down until at the very end, you're like, okay, wow, this is a leaf. Is there, and there's no children, you check, there's no children. Is the sum 0? Because now, like all the math already evened out, and that's kind of the idea behind it. Yeah. As I, in terms of cleanliness, the code cleanliness, I guess I could do slightly better, but I think this is mostly okay. Pretty straightforward-ish. Yeah, I love Haskell for stuff like that. I mean, I love functional programming in general. So that's kind of, so big fan of that. But yeah, I mean, as I said, I think for this problem, I would very much expect this to be an interview. So definitely practice until you're very comfortable with problems such as this. So I think that's all I'm going to say about this one. Otherwise, it's, yeah, just recursion on the root node and then going for it. Cool.